Okay, I'd like to bring to order the February meeting of the Capital Program Oversight Committee. Are there any public comments? Any public speakers? Nope. Okay, that being the case, approval of the minutes from the January meeting?
Second.
All those in favor? Aye. Committee work plan, Craig Stewart.
Yeah, there's one change to the work plan. That is the MTA Capital Construction will give a safety presentation. As you know, other agency presidents provided their presentations in the operating committees earlier today. So that will be the first item on the agenda.
Michael?
Okay, let me just, our safety management system is meant to address the public safety while we build, environmental safety, and worker safety. And MTACC provides the oversight of all safety and the capital projects that are under our control. We have changed, and it's still actually, we're working in this org chart to make it even more clear. Now that it's only very small, it's hard to read, but the Director of Safety will report directly to me. We have today, we are separating safety from what it was project control, so we're bringing it in a different location. Nevertheless, a lot of the functions will continue to be the same. The system management, the safety management system that we employ is basically a four-pronged approach in which we, in effect, we initiate the work at the contract evaluation stage, and we take it all through the life cycle, where we are continuously interfacing with the various elements. The first one, the contract evaluation, what we're doing here is, in effect, looking at the contract plans to make sure that the functions, the safety function, worker, public, and environment are all covered, and we are reviewing that. We evaluate each plan, and then work is only started upon the acceptance of the plan provided. We have meetings with the contractor prior to that, review their plans, and we are proceeding in effect only after that has been done. The compliance criteria that we have in place is dictated by OSHA, EPA. We're looking at New York City DOT, New York City DEP, buildings, Department of Sanitation, Fire, New York State DEC. All of this are looked at as part of the safety compliance of the contractor. The contractors normally have a plan to train. They have toolbox talks, safety committee development, the safety standards, the safety stand-downs in which they actually stop work and talk to their workers every so often. Particularly, some do it on a, and we're now instituted, they have to all do it rather than do it in reaction to an incident. In the past, they've done it as reactive to an incident. Now they're doing it continuously. The second element is really the safety planning, and that is primarily the contractors. We look at targeted safety plans depending on what they're doing, and each one, each major safety function is covered: the worker, environmental, and public. We look at safe work plans, including blast plans, and this is something that now is in the past, but that will remain in terms, because there will be future projects requiring that. The construction work plans, and that has to do a lot with sometimes activities that are very, very sensitive, such as underpinning of buildings. We look at the maintenance and protection of traffic, because this is in the middle of the street and we need to make sure that the public is protected. We look at environmental compliance, and we talk about the air, noise, quality, and then evaluation of adjacent structure. Particularly, we had to do that on 2nd Avenue, where we built, we had about, in the first phase, 225 buildings that were actually we needed to protect. And then these plans are evaluated against the contractor's tasks. And last but not least, we approve the plans before they proceed, and we make sure that we identify various activities that will reduce the risks. The third item that needs to be addressed, is the evaluation of the safety plan. Here we look at the execution, and we evaluating the worker safety implementation, look at hazards, logs, statistical incident rates, we do quarterly audits, and then above all we monitor the air quality, dust control system, vibrations, and in effect adequacy of the maintenance and protection of traffic. The fourth element is the contractor management, and we do that, we review that, we evaluate their operation, and we provide feedback to construction management personnel in order to effect change. And a lot of it has to do what we believe is feedback from lessons learned. Is one of the first times that we built in such a dense urban area, and we needed to be able to do that. Example of one of them is an incident that sometimes last summer we had a vehicle that was hit by another vehicle, and it was pushed through our construction zone, and the front of the car actually ended up being suspended in an opening that was left uncovered by the contractor. The MPT protection area is such that will not prevent a car from actually striking through many times. So it's very important that if we have any openings, they're being covered. And we had identified vulnerabilities after the incident, and we have made the adequate, the required changes in order to adhere to the MPT plan. So that's something that we're doing continuously in order to make sure that we learn from our incidents that happen, and so they will not repeat themselves. One of the things that we do is lost time injury rates. We constantly monitor that. Before the national number before 2010 was 2.5, 2.6. It used to 2.2, in 13 to 2.0, and in 2014 is now been lowered to 1.7. This is actually our annual lost time accident rates, and in 2007 the number was quite high. I'm just trying to, you can see from here, 3.14, and we are now down at 1.29. So we are all right now we are within, well within the rate that is prescribed by the federal government. We have done then for each one of the projects the same analysis, and if you can see at the lower part on the east side access, we are at right now at 2.23. The numbers are going down. When we go to the 2nd Avenue subway, we are right now at 1.93, so we are below 2, and we are looking to have it even lower. And you can see the accidents are the blue, right, and the hours worked are in red, so that gives you an indication of the relationship between the two. When we look at the 7-line extension, we are at actually 1.56, right? And again, this is even below the 1.7 that is prescribed today. We're still carrying 2.0 because that was the last one that we saw. And then, last but not least, is Fulton Center that is really low at 1.13. And that was throughout low. I want to make sure that everyone understands that this is a different type of construction. It was a building vis-a-vis heavy civil construction that we have for the others. So that is also the reason for having such low numbers, although they were very careful to monitor it, but it's a different type of construction. That's about it. Any questions?
If I remember correctly, last year we had a major safety issue with regard to a blasting situation.
2 years ago.
2 years ago.
2 years ago.
Time flies. For contracting situation. What rules were violated in that context, and what consequences took place as a result of them?
The answer is all the rules were violated. There was not one rule that was not violated by the contractor. They went over everything that they should have done. This is the blast that happened at the northwest corner of 2nd Avenue and 72nd Street, where we're having an ancillary building. There was a blast that was supposed to be controlled, ended up being an explosion rather than a blast. We have done an analysis at the time to understand exactly what happened, and we put in place stringent rules for that not to reoccur. Not that we did not have them before, but the problem was that the contractor took upon themselves to go ahead and do something without the approval of the CM. The CM did not get involved to make sure that that happened, and above all, the people that were charged with oversight from the fire department have kind of just did not react to that as well. So the three things together resulted in what happened, and it shouldn't have happened. We had this very weird, actually peculiar situation in which they were drilling the holes for the explosive at an angle. And what happened is that as you're drilling, normally you drill them perpendicular to the surface, so the two, or whatever number of holes we're drilling will never connect to each other. In this particular case, they deviated, and at the very end, they connected. So when you put the explosive in, instead of having a sequential blast that gives you a control blast, we had an explosion, because as soon as they contacted at the bottom, everything popped up, and on top of it, we were blasting a piece of rock that was almost like a projectile to the corner of the site, and it's exactly what happened. The whole thing took off in one shot and penetrated the deck at that location. Luckily, nothing happens in terms of physical damage or anything, so that was the lucky part, but there was a lot to be learned from that.
Thank you.
Any further questions? Okay, we'd like to move on to the next item on the agenda, which is the semi-annual update of the MTA-wide track programs. For those of you who've been around for a while, probably what started the first capital program back in 1982 was the deplorable conditions that New York City Transit was in with respect to track. We had over 700 red tags on the system where there were slow speed orders that affected the daily delivery of service. And in the first 2 or 3 capital programs, the majority of money was spent on rebuilding and replacing track, rebuilding and replacing cars, and also starting an aggressive approach to signals. But the underpinning of all the capital track programs, want to see a presentation on today, starting with New York City Transit. Right?
Good afternoon.
Introduce yourself, David, and who you are.
Good afternoon. David Knights, Chief Officer of Track, Department of Subways. Today I will be presenting on New York City Transit's track and switch capital programs. This presentation will address the items listed, focusing on the 2014 track capital program, CWR investments, and proposed plan for the next 5-year capital program. The New York City Transit system consists of approximately 659 miles of varying types of mainline track, or the equivalent of traveling from New York City to Richmond, Virginia, and back. Depending on the type of track, the life value of track can range between 25 years and 65 years of useful life. Okay. The next 7 slides are pictures of the various types of track within the New York Transit City system. There are approximately 90 miles of Type 1 ballasted track. There are 193 miles of Type 2 short tie blocks embedded in concrete invert track. There are approximately 175 miles of Type 2 modified or Type 2M short tie blocks and long ties embedded in concrete invert. There are 167 miles of Type 3 elevated track. There are 160 miles of Type 6 ballasted track, which you'll find in the open cut sections like the Dyer line. There are 13 miles of Type 7 track, which is long ties resting in ballast used primarily in our yards. And there are 19 miles of Type 8M direct fixation track. We have a comprehensive track and switch renewal program that is carried out using a dedicated in-house construction workforce who does the majority of our track work. One of the main benefits of using in-house forces is flexibility. Flexibility enables us to change locations based on track access availability. We are able to deploy workforces to gain efficiencies and productivity. In addition, we have our own on-site track and switch fabrication facility at Linden Yard in Brooklyn, New York. Another benefit of using in-house forces is for cost effectiveness. There are no mobilization costs, AWOLs, contractors' claims, or profit attained from the contractor. The in-house forces include experienced supervisors and managers with thorough knowledge of New York City Transit standards. In addition, flagging associated with the in-house capital work is performed by our own MOW trained personnel. Next. This chart illustrates the per year mileage of mainline track reconstruction. Between 1984 and 2013, under the New York City Transit Capital Track and Switch programs, we have reconstructed approximately 372 miles of mainline track and reaching a state of good repair in 1991. As a note, in the early part of the capital program, as Tom said, we made huge investments in order to bring track into a state of good repair. You will notice from the chart that the production levels have decreased. Therefore, increased investments may be required in future capital programs to address the aging I&D subway lines. Next. Similarly, this chart illustrates the per year mainline switch reconstruction. Between 1984 and 2013, under the New York City Transit Capital Track and Switch programs, we have constructed 1,206 mainline switches, reaching a state of good repair in 1997. Next slide. No, go back. Thank you. Thanks. The project selection process for the capital track and switch programs are based on the findings of the condition survey, track geometry car, visual inspections, and track access availability. The quadrennial condition survey is performed on mainline and yard tracks and switches. The purpose of this survey is to categorize track access by its remaining useful life. The quarterly track geometry car findings provides information on the track geometry, rail wear and flangeway width, rail floors, thermal imaging, and video inspection. Both surveys and geometry car inspections are performed by our track engineering division. Visual track maintenance inspection performed by our in-house maintenance forces by crews who walk and inspect the tracks on a system-wide basis twice a week on non-consecutive days. As for track access, we seek opportunities to coordinate our program with other planned construction activities in the system, which we know as called piggybacking. The benefit of coordinating work results in cost efficiencies as well as minimizing customer inconvenience.
Could I ask how many track geometry cars Transit has?
We have four.
Four. And they're kept at different yards or all at the same yard?
The oldest one is at
Classified information. We keep them throughout the system.
The production levels for the from 2010 to 2014 capital program include approximately 56 miles of mainline track, 126 mainline switches, yard work, and approximately 8 miles of continuous welded rail. 2014 is the final year of the current capital program. The 2014 capital program consists of 14 projects addressing approximately 7 miles of track reconstruction and 15 switches on the main line, approximately 2.5 miles of continuous welded rail, yard switches, and with a revised budget of $207.9 million. The cost estimates are provided by the Track Engineering Division, and to confirm with standard procedures and to ensure cost competitiveness, an independent engineering estimate is also performed. The estimate includes support costs such as diversions or general orders, work trains, and supplemental bus service. Of the 14 projects planned in 2014, 4 of the largest projects are represented on this chart. They are the replacement of 256 panels on the Brighton line, replacement of 9 switches and 134 panels on the White Plains Road line, replacement of 65 panels on the Pelham line, and the installation of approximately 2.6 miles of continuous welded rail. These projects account for approximately $104.7 million, or half of the 2014 program budget. The ranges listed on the production levels are estimated based on preliminary reevaluation of the last condition survey. Track Engineering is currently conducting the mainline track condition assessment, which will provide the data to finalize the 2015 to 2019 capital track program production levels required to maintain a state of good repair. You will note that the 2015 to 2019 program, we proposed a CWR initiative program in order to address the high number of rail breaks. This will be discussed on the next slide. We have proposed an increased CWR program. CWR has the lowest frequency of rail breaks per mile. Installation of CWR will significantly reduce joint failures found in bolted rail territory or blowhole cracks. As an added benefit of CWR is that it lowers noise and vibration levels. The installation of CWR and resilient fasteners also provides for a longer track life and reduction of stresses in the track structure. The scope of the CWR initiative addresses critical corridors identified by Track Engineering, where the concentration of in-service rail breaks are the highest, and they include the 8th Avenue corridor, Broadway 7th Avenue, 6th Avenue, Queens Archer, and the Astoria line. Just as a note, CWR cannot be used on the structure due to the varying expansion and contraction differences of the actual rail and the structure itself. So on open deck structures, we do not use CWR. As part of our new strategies, we have implemented a Scheduled Component Renewal Project, or SCRP. SCRP is a cost-effective approach utilized for track renewal of the subway in elevated track areas where fasteners and rails are failing. In most cases, the concrete and the cross ties still have years of remaining useful life. The costs associated with SCRP initiative are approximately 1/3 to 1/2 the cost associated of doing Type 2 or Type 3 reconstruction. To aid in our efforts in achieving our goals, we are exploring new strategies and construction techniques, as the introduction of mechanized equipment to assist employees handling heavy materials, for example, a knuckle boom crane mounted onto a work train flat car and a prime mover super utility vehicles. We are in the process of exploring procuring a flashboard welding service contract in addition to refurbishing the welding plant at Linden Yard in Brooklyn. We are introducing lighter, more efficient power tools and more ergonomic type tools for our employees. We have revised work procedures and job task hazard assessments. In addition, the Material Department has assigned a dedicated coordinator to the Track Division to facilitate the material and procurement process. The next few slides are before and after pictures of work completed by our in-house capital track construction forces. Type 3 work at Queensboro Plaza, and an SCRP job north of Northern Boulevard. And that is the end of my presentation. Thank you very much for allowing me to present to you today.
Long Island will be next, and well, if you could hold questions till the end, because each one of the agencies is going to go through their presentation on their capital track programs. If you could identify yourself.
Yes, I will. Thank you, sir. Okay. Good. Okay. My name is Rich Oakley. I'm the Chief Program Officer for the Long Island Railroad, and with me today is Glenn Greenberg. He's the Assistant Chief Engineer for Maintenance Away, which includes track work. He'll help me answer any technical questions you may have. All right, we get used to this. Okay. The Long Island Railroad development of the 5-year capital program takes into consideration useful life, age, and level of utilization. An example of useful life would be the goal to replace 20% of our wood ties every 7 years, which would achieve full replacement over the 35-year useful life of the wood tie. In terms of level of utilization, we typically measure in annual gross tonnage, which is derived by multiplying the standard car loadings and the number of cars that pass over a section of track. The replacement of switches and rail is based on both age and level of utilization. These elements, combined with the latest condition assessment, track inspection reports, and available outages, are weighed into the development of our annual track program. With respect to 2015 through 2019 capital program, the Long Island Railroad will also integrate the recommendations of the Blue Ribbon Panel. Since its inception, the MTA capital program has made a $1.26 billion investment in Long Island Railroad's track program. This includes $51 million budgeted in our current 2014 annual track program. Next. Thank you. Okay. This chart shows the goals and actual quantities installed through 2013 as well as our goals for 2014. We are on pace to meet or exceed the goals set for the 2010 to 2014 track program. Concrete ties. In 2013, we were able to install twice the amount of concrete ties due to productivity gains and available outages. On the CWR, continuous welded rail, the program goals for replacement of continuous welded rail we completed in the first 2 years of our program. We are planning to replace another 160,000 linear feet, or roughly 30 miles, of CWR planned for in our 2015 to 2019 capital program. Over 95% of our track is CWR. Field wells, each year we try to increase the goals for field wells in efforts to reduce the amount of bolted rail connections that we have. The viaduct rail fasteners, we also completed replacement of the original direct fixation rail fasteners on the Babylon Branch viaduct. Available track outages and contact time to do this work is carefully planned through our track outage program. Every effort is made to maximize the amount of work that can be done within an outage by piggybacking projects and consolidating work. When doing tie replacement on specific branches, we will also try to replace scheduled grade crossings, field welds, rail grinding, as well as replacement of track systems such as third rail, signal, and communications. The outages required to meet the goals shown for 2014 are illustrated on this system map, which includes wood tie replacement on what we call mechanized tie replacement will take place between Ronkonkoma and Greenport on the central branch and between Divide and Farmingdale. Concrete tie installation will take place between Locust Manor and Oyster Bay, Hempstead Branch, and other isolated locations. This chart reflects the proposed scope for the 2015 to 2019 program and is currently under development. The track program is heavily dependent on the use of specialized equipment to perform the work in the most efficient manner. The photo on your left represents the lineup of equipment used during our mechanized wood tie replacement operation, which involves over a dozen pieces of equipment. On the right is our track laying machine, which provides a mechanized approach to the installation of concrete ties and the replacement of existing rail. Long Island Railroad has also used third-party supplied equipment such as shoulder ballast cleaners, rail ballast vacuums, and rail grinding machines when it's proven to be more efficient to do so. The 2010-2014 track program also included the purchase of new equipment valued at $7 million. Here is some of the equipment recently purchased. Skid steer, gondola, spiker. The railroad now has over 300 pieces of equipment used to maintain state-of-the-art throughout our Long Island Railroad system.
What does a spiker do?
It spikes.
It spikes.
It spikes, right. Drives spikes into the wood ties. Okay. Right. Here we have a photo of a concrete grade crossing. And we are now utilizing concrete over rubber in hopes to increase the useful life of the crossing. We're hoping to get 30 years out of this crossing. These are other annual track program operations. We have switch replacement, continuous welded rail, field welding, and surfacing. Between 2008 and 2013, the Long Island Railroad replaced all 48,572 rail fasteners originally installed in the mid-1920s on the Babylon Branch Viaduct. The new rail fasteners were custom designed to fit onto the existing concrete pads. This eliminated the need for deck modifications while providing a better quality ride, improved electrical isolation, and adjust the spring rate to lessen the impact of the heavier equipment axles on our viaduct. A total of 11.5 miles of track was rehabilitated. Another state-of-the-art project includes the replacement of the existing half-tie rail fasteners systems on the Atlantic Bridge Tunnel between Jamaica and East New York. The existing system will be replaced with a composite half-tie system that will allow the concrete substrate and drainage troughs to remain. In addition, the new composite tie is expected to have an increased useful life due to its resiliency against water and a change in temperature. The first phase is scheduled to start in November of this year, which consists of approximately 10,000 linear feet of half ties in the most critical locations, with completion scheduled for May 2016. And that concludes our presentation.
Thank you, Rich. If Metro North could now come up and give their presentation. Bob, when you get started, please identify yourself and your two associates.
Good afternoon. I'm Bob Pusilowski, Chief Engineer. To my left is Yannick Klasowski, Deputy Director Operating Capital, and Dave Melillo, Director of Track and Structures. Yannick is going to give the 2014 presentation. However, prior to that, I'd just like to say a few words to discuss Metro North's track strategy for 2014 and beyond. Needless to say, Metro North was presented with many challenges in 2013. We started off with feeling the effects of Sandy, and to this day still are. We then had 3 derailments, an employee fatality, a major power outage on the New Haven line. This was followed up by 4 NTSB investigations and then the FRA deep dive. We see 2014 as an opportunity to make significant changes to reestablish Metro North's reputation as an industry leader. We are implementing significant changes in our track construction, maintenance, and inspection methodology. Many of these changes are a direct result of recommendations that have been made by TTCI, a subsidiary of the Association of American Railroad, who are leaders in the industry regarding best practices and methodologies regarding track construction, maintenance, and the implementation of new technology. We have been actively working with TTCI since June 2013, and we have tested all of our tracks with their track geometry and loading vehicle. We also have been working with the MTA Blue Ribbon Panel. They were established in September of 2013, and they are compromised and recognized with some of the leading industry leaders in the track world. And then we also plan on implementing the FRA's deep dive recommendations based on their report due later this year. During 2014, the following changes have either already or in the process of being implemented. The 2014 Track Capital Program, which is being presented today, has been developed using information generated from TTCI's track geometry vehicle. We have also used ground penetrating radar data that has been collected, and the information that we have collected from the track inspector reports. State of good repair programs will be a condition-based program versus previously we were just using asset life cycles. Development of an enhanced track surfacing program is being developed. 2 additional crews will be added to our surfacing program, and an enhanced joint elimination program where we have added 1 additional crew to do the elimination of joints by welding. The latest technology detecting internal defects within the rail will be used by our contractor, Sperry Rail, and they perform this measurement twice annually. A complete reorganization of the track department with several significant changes in the oversight and management of the department, such as track geometry will be performed quarterly. TTCI will be performing 2 of these measurements in 2014. We are exploring the use of autonomous track geometry, which track geometry measuring equipment is added to the revenue fee, and track conditions are constantly being monitored. New technologies and automated inspection of joint bars, ties, and fasteners are also being explored and will be tested in 2014 by companies of Georgetown Rail and Sperry. A manager will be dedicated to the oversight and data management of all the electronic information we'll be collecting. This information will be the basis of the development of the future track programs. A quality assurance function for the track inspections and the construction and maintenance of track is being developed, insurance compliance to FRA and Metro-North standards. Development will begin this year of a comprehensive track asset database to include electronic track inspections, trouble reporting, documentation of incidents, and corrective actions being implemented. Enhanced training and mentoring programs from track inspections and the surfacing equipment operators has been developed and on the verge of being implemented. Dedicated track engineering function is being established to perform all track designs and the maintenance of our track standards. As I stated earlier, 2014 is a year of opportunity for Metro-North. This is the year that will be noted as the year Metro-North began its return to being an industry leader. With that, I turn it over to Yannick Kozlowski to present the 2014 Metro-North Track Plan.
Good afternoon. On the first slide, I'd like to start off. There we go. Good afternoon. I start off to mention that about 1/3 of our railroad lies in Connecticut. Though this briefing is about our program in New York, I will occasionally mention Connecticut and for comparative purposes. If you look at the chart up there, you notice that approximately 1/3 of our trackage is in Connecticut, 2/3 in New York. This does not include the exempted Beacon line. Beacon means that we run no service there right now. It's basically a mothballed line. Next slide. Our right track values are the same as those of Long Island Railroad and New York City Transit. I'd like to point out on the balanced track for concrete ties, we, MBTA and Amtrak, did go in and buy some ties from a company called Rokla about 10 years ago. The ties had some manufacturing defects. They're failing on us now. We're replacing them under a special court deal with the company, and otherwise the concrete tie track is designated to last for 50 years. On the concrete slab balance track on Park Avenue Viaduct, the viaduct itself is good for 100 years. The mounting system is also very robust, but the grouting system underneath, which levels out the rails, right now we're experiencing some problems with. Working with the manufacturer, come up with a better grouting system. That's what holds the time frame down to 20 years. Next slide. Yes.
Going back to one-third track in Connecticut and two-thirds track, I'm sorry. One-third track in Connecticut, two-thirds track in New York, is that just the New Haven line or is that all of Metro North?
That's in Connecticut. It's a New Haven line in Connecticut, sir, counting all the branches.
Right.
And then for the rest of Metro North is all the rest of Metro North, to include West Hudson.
Okay, so in toto,
In total.
one-third in Connecticut, two-thirds in New York.
Yes.
you.
Approximately. Approximately.
Thank
Yes. Slide. Yes, thank you. These figures indicate how much we have spent so far in this capital program and are going to spend this year. The breakdown is on the left-hand side in New York, 75%, 25% in Connecticut, for a total of $200 million. Next slide. On this slide, please note that we include the New Haven line in New York State only. I will show you a New Haven line data on a Connecticut slide on the following slide. The 2013 program execution was delayed by our response actions to several incidents and to our addressing of drainage issues last year. We are going to complete the 2013 work by the middle of this summer, and then we will tackle the 2014 program in the late summer and fall of this year. Weather dependent. So you notice down there the 70%. The 70% there in the percent complete column from 2013 is as far as we got before we switched our focus. Next slide. Looking closer at this year for 2014, we're looking at the cyclical track program. Excuse me, Connecticut. Looking at Connecticut over here, this slide presents Connecticut data. Connecticut projects in the program this year are 1 to 2 years out. And if you notice over here, Connecticut, the way they fund their program is approximately 1 year at a time, and they fund during the year of execution. Now, what happened in the year 2013 is that we diverted some of our forces working in Connecticut down to the problems they were having for drainage issues and in construction CP 109 in the Bronx. I will cover those later on in this briefing. But that means that we only completed 49% of our projects in Connecticut. This year we will catch up in Connecticut and complete the 2013 work and then do the 2014 work. As of right now, 1/2 of the Connecticut program is funded for this year. We do expect the rest of the funding to show up for the rest of this year.
Could I just ask?
Yes.
When you're referring to Connecticut, are you referring to the Danbury branch, the Waterbury branch, the New Canaan branch, and the main line to New Haven?
Correct. From the Connecticut-New York border
Right.
east.
Okay.
Correct.
Thanks.
Yes. Next slide. Looking at the cyclical track program specifically, though the weather has not been very cooperative, we were able to get a little bit of rail put in during the nice weather we had this past month, last January. May have forgotten about it, but we did have some nice weather. It equates about 0.8 miles of rail that was in bad shape, and we were able to replace that. Otherwise, we're replacing 7.6 miles this year. In Connecticut, another 1.9 for a total of 9.5 miles of continuous welded rail to go into our track structure this year. Next slide. Okay. Looking at the cyclical track program for ties, the emphasis this year, as you notice from the Connecticut slide, is going to be on putting ties into Connecticut. And we're putting in 30,000 ties in Connecticut. So New York is a little bit on the lighter side. Having said that, in New York, the primary emphasis is going to be on the Hudson line for our tie program. That's the one that got really hit by Hurricane Sandy last year. Next slide. Surfacing. Surfacing is basically smooths out the track, and it also prolongs the longevity of our track. It's equivalent to fixing potholes and cracks out on a highway. When you go ahead and seal up the cracks, you get a smoother ride, and the road surface wears better and lasts longer. That's basically what surfacing does for our track. Our goal is to surface 120 miles per year. Here you see we're doing 88.2 miles in New York State. When added to Connecticut's 30 miles, brings us up to 118.2 miles, just under the 120 that we for our goal for the year. Next slide. For the switch program, please note that almost half of this budget is for CP 109. CP stands for Control Point. This is a brand new installation that we're putting in the Bronx, roughly around the Botanical Gardens. It is along a 6-mile stretch of trackage where we have no ability to have trains switch from one track to the other. So we're breaking a whole stretch into 2 halves, approximately equal in length, about 3 miles and 3 miles. it will do two things for us. It'll allow us to improve our on-time performance, because any trains that get stuck in this extremely busy section of Metro North right now force us to have to back trains up to the nearest control point and send them down another track. This will at least break that whole area down into two halves and allow us to bring on-time performance to a much better line to what it is right now. The second thing that it allows us to do is this is a very difficult location for us to do track maintenance on, because when we take out a piece of track here, we are taking out 6 miles of extremely crucial track. By putting in this control point, we'll be able to break it down to 2-3 mile segments and therefore decrease the amount of pain that we have when we do track maintenance. So having said that, approximately 22.7, 23 to $25 million of this project right here is to install that new control point. That includes all the signaling, the power distribution systems, and connecting to our control center. It also includes the purchase of materials for next year's track program. Now, next year's track program is the next capital budget from 2015 to 2019, but we're beginning to buy the items under this year's program. Next slide. The mainline switch program in comparison for Connecticut, as you can see, we have 2014, we plan on putting in 12 turnouts. We have half of them funded right now on schedule. The other half we hope to have funded by the end of this year, so we can go ahead and actually put them in this year. Next slide. The mainline switch program for 2014 for New York State. You notice CP 109, 7 turnouts right there. Last year we meant to put in all the turnouts in CP 109. However, once we discovered, as we began to put in that CP and we looked at that whole stretch of track, that we have a lot of drainage issues. We decided to focus and fix those drainage issues first because they were causing us tremendous problems. So all the effort went to fixing the drainage issues. We're only able to install 3 of the 10 turnouts in CP 109. This year we plan on finishing up CP 109, weather permitting and conditions permitting. CP4 and CP5 is an area, it only has, you can see, 3 turnouts in there. That also includes a lot of ancillary track work. This is Mott Haven in Bronx. This is where our Hudson Line and Harlem Line split, an extremely busy junction on our railroad. A lot of complex track work right there. The photograph is of a portion of the Mott Haven interlocking right there, and we'll be devoting our primary focus on that, and then we'll go to CP 109. Next slide. For West of Hudson, we perform all of our program work for West of Hudson in the fall of each year. New Jersey Transit performs this work for us under contract. For all track work, for turnout work, or switch work, we do our own in-house work for that. If you notice that in 2011, we did not do well because when Hurricane Irene hit. And you see the top right photograph there is part of the aftermath of Hurricane Irene. We then devoted the rest of that year and the beginning of the following year to reconstruct our main line, which was completely severed for approximately 14 miles. So we completely rebuilt that. However, we want to get back into our program. So in 2012, we went ahead and we knocked out the 2011 program that we were supposed to have done when the hurricane hit. And then in the fall of 2012, we went ahead and we did the 2012 program. Now, based on the fact that we were able to knock out 2 years' worth of work, we worked with NG Transit this year, and they were able to really bolster their forces together and completely with our forces, we were able to knock out the 2013 and 2014 program in the fall of this year. The only remaining work on the West of Hudson program right now is that to install 2 turnouts, which we will do on Metro North with Metro North forces later on this year. Next slide. For the Grand Central Terminal switch program, we're on track to replacing these turnouts. We're on approximately a 4-year cycle here. We're replacing 4 program cycle, so that every 20 years we wind up replacing almost all of our turnouts. We replace them much more frequently than do on the main line, primarily because Grand Central sees the most traffic of anywhere else on our railroad. Grand Central terminals build extremely sharp curves, which causes the trains to exert tremendous lateral forces on the track structure, which goes ahead and further breaks down our turnouts. And the turnouts just basically take a lot of wear and tear. The other problem with in here is when the New York Central Railroad built Grand Central Terminal, they built a track with very specialized. These are non-standard sizes of track that are here. Very specialized crossings and everything else. And so they have long lead times because they're all custom built, custom made. But we're on track to going ahead and replacing 44 of those track components for the next program. For this program. Next slide. Our goals and project selection process is look at the expected life versus the actual conditions. I won't go into a lot of detail because Bob Puslowski gave a tremendous overview of what we are doing right now. Just to piggyback off what we were saying for track geometry cars, what the track geometry vehicle does is it determines the position, the curvature, and the alignment of the track. Goes down and sees exactly, is the track exactly as straight or as curved as it is supposed to be. It also checks the smoothness and the cross level of the track. Are we bouncing down the track as we go down the track, yes or no? And it also can check out for us, and checks out for us, our overhead catenary system, the overhead wires which carry the current on the New Haven line, to make sure that it's at the correct height and the wires come properly staggered as you go down the track to minimize wear and tear on the pans up above. So that's the type of information that we're getting from track geometry findings. Bob also mentioned the TTCI, the Transportation Technology Center's track loading vehicle. What this vehicle does is it exerts special force on the track to replicate the forces of either a heavy freight train, and to include not just the vertical but the lateral forces, or also of extremely fast passenger trains, like we have the Acela Express operating on our New Haven line, Amtrak's Acela. And so we can replicate those forces of that vehicle, which is fully instrumented, and tell us how our track structure responds to those forces. Gives us a much better idea of what our track is really capable of handling and where the problem areas may be. Also on spare rail service, you see a photograph down there of a spare rail car. This is the technology that lets us look inside of the rail to see where there are any flaws inside the rail, stuff that normally would never be detected by the naked eye or any other technology. They help us determine where there might be a rail break coming up so we can go ahead, cut it out, and replace it before it happens. Next slide. The 2015-2019 cyclical track program, I'll have Connecticut shown on next slide. This is for east of Hudson only. I have a Connecticut slide and a west of Hudson slide also. You notice that for the ties, that comes out to be about 25,000 ties per year, which will bring us to a state of good repair. Same with the welded rail. Servicing comes out to be about 120 miles per year. The photograph that you see in the bottom left corner is that of a double slip switch. I mentioned it a couple of times here on the slide. Just wanted to show you what it's like. It's a very complex switch. It has to be aligned in 4 different directions. This particular photograph is all the 2 switches we have to replace in Croton Harmon, New York at CP control point 35. Next slide. Looking at our Connecticut program, as I mentioned, Connecticut plans its capital program 1 to 2 years out. Therefore, this is the 2015 to 2016 program, not the 2015 to 2019. It also funds in the year of execution, so there is no funding associated with this program right now. This is what Connecticut is looking at over the next 2 years, what we have worked on with Connecticut. Next slide. For west of Hudson, this is what we're planning on doing to maintain ourselves in a state of good repair. Next slide. For new strategies, construction techniques, one more time just to piggyback off of what Bob said, an excellent presentation. The ground penetrating radar, it lets us detect old culverts that may have been covered over the years, but which are a point of failure underneath our main line, which no one ever knew was there. These radars help us find those, underground streams, irregular rock and ground formations, and so forth. That helps us put together a much better program to having smooth track. Rail grinding machines, we're bringing those in. What happens when trains stop and go, it causes corrugations in the top of the surface of the rail. It sort of looks like a cardboard box that's corrugated. That's what the rail begins to look like. That smooths it out. Does 2 things for us. Number 1, it gives the passengers a much smoother ride. And number 2, it helps our equipment last longer, both our rail car wheels, and it also helps prolong the life of the rail because we restore the profile of the rail. And the rail is nice and smooth, it lasts longer. So that's what rail grinding does for us. I mentioned that the track geometry vehicle, the 2 surfacing crews, to piggyback off what Bob said, we will now have 1 dedicated to each of our east of Hudson lines, and then we'll have 1 additional crew which will go to where all of our problem areas are. We can use them for spot surfacing, and also we will use them for all of our control points because they get additional wear and tear because they have the switches in there, and that's where we're going to tamp and surface more.
A quick question.
Yes, sir.
This says that the track geometry vehicle is operated quarterly. If you have a prolonged period of snow on the ground, I assume it's done once the snow is gone? Or can it be done with snow?
Snow typically prohibits. If you have the snow is above the rails, you're not going to do track geometry. If it's at or below the rails, you can do the measurements.
So if it's scheduled and there's snow, it's done as soon after the snow is gone as you can do it?
Typically
it doesn't wait for the next quarter, in other words?
No, absolutely not. Absolutely not. Typically it'll be about March, somewhere in June, July. Then you come in September, October, and then December about the last run for the year.
And finally, we have our rail vacs. You see a photograph of it in the bottom left corner. It's a humongous vacuum cleaner. When it comes to excavating around the track, why dig it out? We can just suck it out. It's a phenomenal machine. We use these. It really has helped us improve our track maintenance and the speed of the maintenance. That concludes my presentation.
I'd like to
Any
make
questions?
a couple of general comments before we open it up to questions. I think what you've seen from each one of the three agencies is an excellent presentation on their approach to cyclical track replacement on the capital program side. On any of the agencies, one of the largest cost drivers is capital track. And what you've seen, and we didn't hear it specifically from Metro North, but we did from Long Island and New York City Transit, moving from what at the front end of the program in the 80s was what we called out-of-face reconstruction of track, where we did everything and reconstructed and changed from one type to another type at large dollar values, is moving toward what you could call the initial elements of whole life asset management, where you're only replacing those elements that have reached the end of their useful life, and your discretion, using discretion with respect to the expenditure of those dollars. You know, the New York City Transit program can range anywhere from $240 to over $300 million a year, and so those are resources we've got to husband very carefully. So I've asked all the organizations to make sure that as they move forward, going from what started as crude condition surveys and assessments and 20-year needs to move toward whole life asset management, where we have much finer detailed information to make these decisions by, because the programs keep getting larger, the competition for resources keep getting more difficult, and we got to make sure that this particular asset is well covered off. The second item I'd like to mention is from this day forward, we are going to specifically make sure we call out in the Metro North presentation those dollars that are expended for New York maintenance related, because those are funded out of New York funds. Connecticut is funded out of Connecticut funds. And for lack of a better phrase, our relationship with Connecticut as a contract operator and maintainer is one that requires vigilance, because we need to make sure that we're doing everything there in terms of keeping up our responsibilities with that agreement are in place. Okay, thank you. Craig, do you want to introduce the
Sure.
next speaker and presentation?
Okay. Okay, this next presentation is provided by the MTA Capital Program staff, and it's on Sandry-related efforts across the agency. We've asked the agencies to come in April and provide specific updates on projects, and that'll happen at the April CPOC meeting. Naomi Rennick is Deputy Director of Federal Policy and Recovery Projects, will provide an overview of the Sandy program, and following Naomi, Steve Barang, Director of Capital Program Management, will give a brief demonstration on the new features of the Capital Program Dashboard, which features an application for the Sandy projects. Naomi?
Thanks, Craig. Hi, good afternoon. As Craig said, folks at the agencies will be back in April to give you more detailed descriptions of their projects that are ongoing. For today, I'm going to give you a quick overview of where we are. I'm going to recap our damages, talk briefly about some ongoing capital work, give you a summary of the funding situation, and also talk for a minute about our approach to resiliency. So I think you've all seen this picture before. I just wanted to bring it up because it reminds us of the magnitude of the storm that hit our region in October of 2012. And here we have some images of where the damage occurred. The picture of Lower Manhattan, the red and orange, shows where there was flooding during Sandy. The two Long Island Railroad pictures, there was flooding in the areas that are in blue. And in the Metro North territory, there was flooding along 30 miles of the Hudson Line and wind damage in other parts of the system. Water entered the system through anywhere that there was an entry. There are thousands of openings to the subway system, just 600 in Lower Manhattan alone. They're the same types of openings to the East River tunnels that are used by Long Island Railroad. And water entered the system into yards and vehicular tunnels directly from the storm surge, whether that was from Coney Island Creek, Hudson River, the East River, Newtown Creek, or other areas. Track at grade and low-lying areas also flooded, such as the Hudson Line and the Long Beach branch. Overall, the damage is estimated at close to $5 billion. That's the amount that was included in the plan amendment that was passed in January. 130 million gallons of salt water were pumped from tunnels across the MTA system. Damage included to 9 subway tubes, 2 vehicular tunnels, 2 of the East River tunnels used by Long Island Railroad, and in yards, low-lying areas, including stations throughout the system. And anywhere that water came into the system, this was brackish salt water that causes corrosion, and this corrosion continues until permanent repairs are made. There was also wind damage throughout the system, canopies and roofs to outdoor stations, and trees fell across the track, taking out catenary throughout portions of Metro North and Long Island Railroad territory. Most of the damage occurred in concentrated areas where assets were already in a state of good repair, so we are replacing many assets prematurely. As we move forward with the recovery, our primary goal is to minimize the impact of our recovery work on the system and our customers and also the regional economy. Figuring out how to do this includes many steps that involve multiple departments at each agency. The work began with the initial damage assessment that was done shortly after the storm, and that was the first step to understanding our repair needs. But the damage assessment really is an iterative process, and staff at each agency are conducting more frequent inspections and monitoring changes in asset performance to help us understand where there may be latent damage, which would affect the work that we need to do. So the first step in identifying the projects is to determine which assets need to be repaired and which can be replaced, and then identify which assets should be addressed together as part of a package. Part of this work involves evaluating the costs of different packaging scenarios. Once we have the project scoped together, contractor access plan needs to be developed, and that involves a detailed analysis of ridership patterns, available alternate service, and capacity constraints. So are outages needed? Can outages occur just on nights and weekends, or is full-time outage needed, as we have now on the Montague Tube? We also estimate the cost of these different shutdown scenarios in making that determination, and also see if there are any piggybacking opportunities to do work on outages that were already planned. We're currently doing work for Sandy-related repairs in the Steinway Tube using outages that were previously planned for CBTC installation. So as you can see, we have a huge portfolio of work underway. This slide shows some summary information. We have almost $800 million in contracts that have been awarded. That includes design, planning, scoping, and also construction. The work at TBTA is progressing using FEMA funds. The other MTA agencies will be funded by the FTA. In both cases, we're using our own money to advance projects once we are reasonably certain that we'll be reimbursed by the feds. And we're only advancing those projects for which we have that fit into the current funding envelope that we have. The Sandy relief bill that provided money to the FTA and some of the funds for FEMA included a requirement that agencies establish a monitoring process. To that end, MTA Audit and the MTA IG have dedicated staff to monitoring our Sandy program. As work ramps up, they may augment their internal work with third-party monitors as needed. Again, you'll hear more in April about specific projects that each agency is progressing, but some examples of work, of ongoing work, includes repairs in 3 tubes at New York City Transit, Montague, Greenpoint, and Steinway, work at the Clifton Shop in Staten Island, facilities at the Stillwell Terminal in Coney Island, and security equipment in 6 of New York City Transit tubes. At Long Island Railroad, work is underway in the Long Beach branch and also to the First Avenue substation that goes to the East River tunnels. Bridges and Tunnels has work underway at the Cross Bay and Marine Parkway bridges, and Metro North has restoration on the right-of-way, including stabilization of the shoreline and tree clearing throughout the system. Some contracts that are going to be awarded soon include the Beach 116th Street Station in the Rockaways, permanent power, signal and communications work, repairs along 30 miles of the Hudson Line. We're going to continue sealing system openings to the subway system, and particularly in Lower Manhattan. And at TBTA, they're preparing RFPs for electrical, mechanical, communications, lighting, and other systems in the Hugh L. Carey and Queens Midtown tunnels. We are also nearing completion of the design for the permanent restoration of the South Ferry Station. Wherever possible, resiliency is being integrated into repair projects. For example, Long Island Railroad and Metro North are rebuilding substations at higher elevations, and in the Montague Tube, they are strengthening the duct bank that was damaged during Sandy. The agencies, each agency is also in the process of establishing design guidelines to allow resiliency, to establish how resiliency can be built into repair projects as part of the core program. So where do we stand in terms of money? The FTA has allocated $3.8 billion to the MTA. Almost $900 million of this is designated for resiliency work. We've executed grants for just over $1 billion with the FTA. Most of these funds are for repairs, but it does include some money for resiliency work and some also for emergency work that was needed immediately after the storm to get the system back up and running. FTA recently published a solicitation for a competitive grant program for $3 billion for resiliency projects. Applications are currently in development, and that program is open to all states that were under the disaster declaration for Sandy, so up and down the eastern seaboard. The FEMA program works a little differently, and funds are allocated only when there's agreement on project scope and cost. So to date, we have, FEMA has approved about $12 million for repairs in the TBTA system. Negotiations are currently underway for costs to harden and make permanent repairs to the two vehicular tunnels. When we think about resiliency and how to harden the system, many of our assets by their very nature can't be physically moved. So we're taking a layered approach to resiliency that involves a couple steps. The main objective is to keep water from entering the tubes or flowing into low-lying areas. So this might involve work such as what's currently underway in Lower Manhattan to seal certain openings to the subway system, or to build walls or other barriers around yards or other low-lying areas. If water does come into the system, the goal is to pump it out quickly and ensure that equipment in those areas is as watertight as possible. New York City Transit is in the process of converting a few older rail cars into pump trains to increase their pump capacity to that end. The last piece of the layered approach involves projects to expedite our recovery and make systems more resilient. This might include improved emergency communications, emergency generators, and other emergency equipment, or also projects to increase the resiliency of the overall transit network, including higher capacity signaling in Long Island Railroad's East River tunnels, or the Penn Station Access Project, which allows Metro North New Haven line trains to come in over the Hellgate line, avoiding the single point of failure of the Harlem River Lift Bridge. This slide includes some examples of resiliency concepts. Most of these fall into the first category of protecting assets and keeping water out of the system. As I said, the FTA competitive program has applications due on March 28th. The plan amendment that was passed for resiliency measures included almost $6 billion in needs that we identified. The FTA's competitive program provides $3 billion that's open to competition for agencies throughout the region. So we're in the process of prioritizing our projects for submission. And the main points that we're considering in doing the prioritization is the cost to repair the asset if the resiliency project is not conducted, the potential impact to customer without the project, the likelihood of repeat damage, the overall cost of the project, and also the project's role in increasing the overall resiliency of the transportation network. FTA's funding decision is expected in the fall. On the FEMA side, resiliency principles are the same, but the work will be approved as part of negotiations for the repair project. So as part of the repair work for the Hugh L. Carey Tunnel, Bridges and Tunnels is looking at raising the seawall of the Governor's Island vent building, and that will be negotiated as part of the repair package with FEMA. The April report, again, from folks from the agencies, will include more information on which projects we advance through the FTA program and also status of the recovery. Thank you. And Steve is going to walk you through the dashboard for Sandy, which will provide information on our Sandy program.
Good afternoon. As you know, that the MTA is strongly committed to transparency in its capital program, and the MTA Capital Dashboard is one of our most important transparency initiatives. We've recently completed an update to the dashboard that changes the feel and the look of the dashboard, and that is allowing us to add Sandy projects to it. Just as a bit of a health warning, The dashboard is designed to be viewed on your computer screen, so visibility will be a little more difficult here, which is why we've handed out to board members printouts of the screen. If we get started by clicking on the Sandy Dashboard tab, last year when we brought the 2 amendments to the board, we created a lot of placeholder projects for large categories such as track restoration, signal work, etc. In the interim, we've updated our strategy and split out a significant number of projects. And what we're going to do today is, using the interactive Google Map, zoom in on one of those projects related to the Montague Tube Initiative, which was, it's a $260 million initiative that were broken up into 12 projects, and this particular project is the fan plant for Montague Tube. This is a $5.1 million project that was split out of a larger line equipment project. So if we click on that, what you see is a summary of the project, a map that gives you the location of the project, and down below design, start and finish milestones, and if it's in construction, you'll see construction start and finish milestones, and then a percentage complete. If we click on the budget history, you see the history of the project. This explains that this was created after the July amendment, and it was created by taking $5.1 million out of the larger $290 million line equipment project. And if we go to the budget detail, this simply shows the same information but in a graphic form. If we close this out, what you see here are some features which are intended to make it easier to understand the breadth of the Sandy program. You see on the bar chart, we show how the program is broken up from track and infrastructure on the left all the way down to rolling stock and bus depot work on the right for $7 million. Down below you see some pie charts. You see it broken up by agency. The biggest chunk there is clearly New York City Transit in that light blue sort of looking color. On the right you see it broken up by needs, primarily resiliency versus recovery work. In the center you see it broken up by phase, and you have in planning, which is the orangey color, then you have in design, and then you have in construction as well. If you scroll down, what you see is a list of all currently 195 projects that are in the Sandy dashboard. When we started out with the dashboard and the amendment, we had 81 projects. Now we're up to 195, and that number will continue to grow as we refine our strategy. That's sortable or by phase, and if you look at that, you can see you can sort by planning phase, design, construction. If we sort by construction, we can take you down to the same Montague fan plant project that we looked at previously. And so what the dashboard allows you to do is to go by map to your location, or you can go by sort by agency or by the phase of the construction or design, and look for it that way as well. I'd like to point out that at the top of this we have for the frequent dashboard users, we have a feedback form. And since we're on a cycle of continuous improvement, it would be helpful if you provided feedback to us so we can, what you like, what you don't like, so we can make it better. And the last thing I'd like to do is point out for you, if you go to our dashboard, how you get to to our website, how you get to the dashboard. So if you go over to the right, there's a tab that says transparency, and if you click on that, there we go. It brings you straight to the dashboard. Today, that will show you that it's a site still in development because we're going to go live with the Sandy dashboard information in a few weeks, but that's how you will get there when it goes live. Happy to answer any questions.
Okay, the last presentation is Craig Stewart, Capital Program Status. Hearing none, I have a motion to adjourn the meeting. Seconded. All those in favor? A couple minutes and we'll right into governance.